All right, hello. Today we are working on completing the square. There's a standard there as well. Basically, what we're working on is turning a non-factorable trinomial into a perfect square. What's a perfect square? Square and double square, right? Square, double square. The question is, how? All right, so we're going to be pulling a lot of information, like a lot of background information. We're going to be using the x minus h squared plus k to be finding your hk, which is a vertex. We're going to be solving for solutions. We're going to be squaring things and taking halves of things and woo, lots of fun. All right, so I'm just going to kind of start with an example to show you, and then we'll kind of walk through it as well. So let's say we had the example x squared subtract 14x plus 16 equals 0. And I asked you, well, what are the solutions of this? Well, what we've learned so far is if there's no bx, we can just set it, to 0 and solve. But when there's a bx, we can do the negative b over 2a and so on and so forth. But in this case, we would have to factor this one. And you can't factor that because what two numbers multiply together to give you positive 16, but when you add, give you negative 14? I got nothing. Because you get negative 1, negative 16, negative 8, negative 2, negative 4, negative 4. So, you want to say, oh, it's not factorable, but there are solutions. So we're just learning a new way, a new strategy to get those solutions. So what we're going to do is we're going to sort of change this trinomial by balancing sides of the equation is essentially what we're going to do. So the first step is we always move the c. So I'm going to move my c over. All right. So now I have x squared subtract 14x. I'm going to leave a space here is equal to 16. I'm going to put a little space right here. Okay, so I subtracted 16 on this side, and I subtracted 16 on the other side. I should put that negative there. Okay, because again, we have to balance the equation. Whatever we do to one, we can do to the other. All right. Now, the next thing you would do is you would check, is there a coefficient other than 1 for my a? In this case, no. If there was, you'd have to divide it out. You have to have a coefficient of 1. All right. And you always want to see if you can factor anything out as well in the beginning, like a GCF. But so you want to check to factor out a GCF and make sure the coefficient, your a, is just 1. Okay, because it needs to be in the form of x squared. All right, so now the next part, because remember this has to be square, double square. I got this negative 14 by doubling the c and the a. Well, a was 1, so it has to be 2 times 1 times what would give you negative 14. That's essentially what we're doing. And then square it. So how you undo a perfect square, right? Getting back to where we need to be. So I am, turn this way a little. Okay. How you do that is you're going to take your b over 2 and then square it. Why? Because remember, squared, double squared. To get this, it was doubled. So to undo it, I have to divide by 2. And the last number is always squared. That's why we are squaring it. Okay, right? Because square, double square. I got this by doubling it. So to undo it, I have to divide by 2. And I have to square it to get my last square. So in this case, it's negative 14 divided by 2 squared. The negative 14 divided by 2 is 7. 7 squared, negative 7, but negative 7 squared is positive 49. And if you're going to add it to this side, you have to add it here because it has to be balanced. So far, so good? All right. Give you a second. You can write that. Okay? All right. So now we're just going to work it out from here. What is negative 16 plus 49, or 49 subtract 16? Well, that's a 3. What is that? 33? 33 is equal to x squared minus 14x plus 49. It's a negative and it's a positive. So now we can write this as x minus 7 times x plus 7. Following so far? Because all I did was I took, now it's a perfect square, you see? And we should know these are our special cases. So we should know how to factor these easily. When it's in the form of square, double, square, pay attention to the signs. Oh no, what did I do? Look at me, stop it. It's x minus 7 squared. If I did that, there would be no 14. It's just x minus 7 squared. If I wrote what I had before, the plus 7 minus 7, the b of x would be gone because it would cancel out. So sorry, I was paying attention to my signs here. Whenever there's a negative, you carry the sign of your b. So it'd be x subtract 7 squared. X subtract 7 times x subtract 7. Okay, so far so good? All right, so now we can get the solutions, right? And how do we get the solutions? We just solve it. I forget I have to lean back this way. Okay, so now what I look at is this is now solvable. Okay, I can get x by itself. First and foremost, I have to get rid of my square by square rooting. I can square root here. Now, if this was a negative over here, you'd know right away there's no solutions, right? Because you can't actually root a negative number. We're not there. We're not dealing with i's. So now I have x subtract 7 is equal to plus or minus the square root of 33. How come that's the case? Is because whenever you square root something or square something, the answer you get could have been a positive or negative because it's in a parenthesis. All right, so now I have to set up these two problems. Well, what is the square root of 33 equivalent to? 36 is 6, 25 is 5, 33 is really close to 36. Let's be accurate with that. It is 5.74. So now we have x subtract 7 is equal to positive 5.74. And we also have x subtract 7 is equal to negative 5.74. We just solve algebraically. Add 7 to each side. So x is equal to roughly, right, because this is probably an approximation. Obviously the decimal went on and on because it's irrational. Make sure I'm right on that. Yeah. Okay, so this is 12.74. 5.7 subtract, or 5.74 subtract 7, be $1.26. Yeah, x is roughly 1.26. And there are your two solutions that you really wouldn't have been able to get factoring it traditionally because there weren't any whole numbers that could factor to give that to you. However, there were solutions, and that's why you use perfect squares, because it'll give you the actual solutions. So basically what are we actually doing is we are converting our trinomials into perfect squares by balancing both sides of the equations, right? Whatever we did to one, we're doing to the other, so that we can formulate our solutions. And as you can see, it's crossing the x-axis, not at whole numbers. It's crossing the x-axis, in between points. And that's why it seemed to not be factorable in the beginning. All right, so let's do another one. But key things to remember: you use it when non-factorable. You could really, I guess you could use it all the time, but when it's not factorable, you make sure that your coefficient of a is 1. If it's not 1, you divide everything out. Move your c over, divide your b by 2 and square it, and you add it to both sides, again balancing your equation. then whatever you end up with on the left is going to be some form of a perfect square. That's why we're doing completing the square. So it's going to be like a plus b squared or a minus b squared equals whatever you got as your sum from your c plus the b divided by 2 squared number. All right, and then you solve from there. And again, this is what it looks like. Let's go ahead and take a look at another example. Shortcut here, easy, right? If I divide this by 2 and square it, boom, there it is, right? Because square double square. Divide by 2, square it. That's the biggest component there. All right. Let's get another example. Next one that we're going to try, m squared plus 12m plus 19. All right, I can see right away I can't factor this because 19 is prime, so 1 and 19 will never make 12. So I know it's not factorable with whole numbers. So the new method I've learned is completing the square. So I want to make sure that my a is 1, which it is. If it weren't, I'd have to divide everything out. All right, and next I need to move my c to the other side because I need to make room for the perfect square. m squared plus 12m blank is equal to negative 19 blank, right? I move the 19 to the other side by subtracting on both sides. I put that blank there so I don't forget to add the half b squared to each side. My next step is I take half of my b and I square it, right? Because to get 12, I had to double what was my original. So I'm going to take half of 12 and then square it. Well, what's half of 12 is 6. 6 squared is 36. I'm going to add 36 to each side. Okay, so this is what we got so far. Again, make sure that the a is 1, move the c to the other side, take half of our b, square it, and add it to both sides. Now look, I have a perfect square. Perfect square, and it's a positive positive, so this is going to be m plus 6 squared is equal to 36 subtract 19. Is 17. Okay, now I'm going to solve. So get rid of my square, I square root it. So now I have m plus 6 is equal to the positive or negative version of the square root of 17. And the square root of 17 is very close to square root of 16, which is 4. So it's going to be something similar. It's close to 4, let's say, exact here. 17. Exact 4.12. So, right, I'm going to erase what I have so far. Sorry, I'm going to erase what I have so far so I have more room to write. And I'm going to rewrite with the m plus 6 is equal to the positive 4.12 or negative 4.12. Okay, we're going to see what we got so far. All right. So now I have m plus 6 is roughly equivalent to positive 4.12, and m plus 6 is roughly equivalent to negative 4.12, because again, when you square root something, it could have been the positive or the negative. Okay? All right, so now I'm just going to subtract 6 on each side. And this one would be roughly negative 10.12. Yeah. Sorry about that. And then the next one is going to be $4.12 subtract $6 would be negative $1.88. So I could say my two solutions are roughly m is equal to negative 1.88 or m is equal to negative 10.12. And you guys should be able to do, like in 10.5 in the textbook, 9.5, you should be able to do page 579 like numbers 7 through 18 from what we just went over.